So the problem that I have up here is it says it takes a 750 kilogram racing car 9.6 seconds to travel at a uniform speed around a circular track of radius 50 meters. So when they say uniform speed, they mean a constant speed, meaning it's not accelerating, the speed isn't changing, the only thing that's changing is the direction. And this would be a horizontal circle. If you're driving, you'd be driving in, horizontally. So the picture would be, that's how you want to draw your circles when they're horizontal circles. So like the front edge it's sort of like trying to make it look three-dimensional. Like this edge would be out of the board and that would be into the board, so as a horizontal circle. So what we have here is, it says, what average force must the car's tires exert against the track to maintain its circular motion? So in this problem, the average force between the tires and the track is the friction between the tires and the track. So we don't have a string connecting the car to the center of the circle. What's going to allow us to change direction is the friction. So I have friction in that direction, and I'm going to label it. Now, anytime friction is the unknown, I would probably also list my forces in the y direction, because I know we have a formula for friction that says friction equals mu Fn. So I might need to involve the normal force in the solution to this problem. So if I do that, I'm going to have in the vertical direction, I'm going to have the weight and the normal force. So there's my full diagram, my full free body diagram. Now, once I have that, I can now justify writing descriptive equations, because I can look at my picture and describe it. So if I sum up the forces in the centripetal direction, the only force that I have that's causing the change in direction is friction, and it is directed towards the center of the circle. If it wasn't there, then you'd turn the wheel and your car would continue to move in a straight line. It would get further and further away from whatever the center of the circle is. So the formula is friction. Now, friction can either equal mv squared over r or mr omega squared. Either one of those works based on what they're giving in the problem. If the r is not the unknown, and if they're not giving me the angular velocity in radians per second, then I would prefer to use mv squared over r. Let's see. Anytime that I want to avoid the radian unit, because the radian is like a false unit. It's a unit that allows me to go from something that's linear to something that's angular. But it's not, like when I say 1 radian equals so many meters, that's just for that particular circle. So it's not like a true conversion. If I say 12 inches equals 1 foot, that's a true conversion, because I'm going from a length to a length. If I say 60 seconds equals 1 minute, that's a true conversion, because I'm going from a time to a time. But when I say 1 radian equals, let's see, in this problem, equals 50 meters, because that's the radius of the circle, well, a radian is actually an angular unit, and meters is a length. But it does allow us to get from something that's linear to something that's angular. So that's one of the equations that I'm going to have. And then I'll put the other one down. I don't know whether I'm going to need it, but I'm going to put it down right now. So if I sum up the forces that are in the y direction, which is vertical to the centripetal direction, I'm going to get Fn minus W equals 0. So those are your two descriptive equations. If I'm grading this on the test, you're getting a lot of points for just having this down. For identifying that's a horizontal circle and putting the forces there, and then putting your descriptive equations. Now the question is, what average force must the car's tires exert against the track? So that's going to be the friction. So that's my unknown in the problem. And if I look in the wording of the problem, I have the mass. So the mass, I have that. I also have the radius. The radius is 50 meters. What I don't have directly is V. So I know that it says it takes a racing car 9.6 seconds to travel at a uniform speed around the track. So to do one revolution, it's going to take 9.6 seconds. So I can use that information to get my V here. So, and you do it just like you're doing a conversion. I know there are formulas like V equals R omega. I don't even care what the formulas are. I just know that I want meters per second, and I know that I can write this as one revolution in 9.6 seconds as my starting point. So my starting point is 1 rev per 9.6 seconds, and I want that in meters per second. So again, I don't care whether like that is an omega. Okay, this number is an omega. It's not in radians per second, but revolutions per second or revolutions per minute or radians per second, those are omegas. So I could just convert this to radians per second and then plug it into the formula V equals R omega. I mean, I could do that, but why not just treat it as a conversion? Because I can go directly from that directly to meters per second. So that's what I'm going to do. So I'm going to extend the line to the right, and I'm going to go from revolutions to meters. And one revolution means I'm going to move through the circumference of a circle. So what will I be putting in here in the numerator? Well, that would just be the radius. What's the circumference of the circle? 2 pi times the radius. So 2 pi and then 50 meters would be the radius. So if I solve that, I'm going to have all the numbers that I need to actually get the average force that the tires must exert against the track, which is the friction. So what do you get when you solve this? So it's 2 times pi times 50 divided by 9.6. 32.7. And with that number, now we can just plug it into this problem here. So friction is going to equal mv squared divided by r. So the mass in the problem is 750 kilograms. We just solved for the v, 32.7 meters per second. And the radius of the circle is 50 meters. So solving that, and I hope you get to 3 significant digits. Is it 1.60 times 10 to the 4th with those numbers? Yeah, again, 16039. So to 3 significant digits, that would be 1.60 times 10 to the 4th newtons. So there's your answer for part A. Now for part B, it just says, what's the acceleration of the car? Well, F equals ma. We know what the force is, and we know what the mass is, so it really is just rearrange this equation to solve for the acceleration. So our generic formula is Newton's second law. F equals ma. Well, in our problem, the F is friction. So if I want to know what the A is, the centripetal acceleration, it does say centripetal, right? Yeah, what is the acceleration of the car? The only acceleration of the car is centripetal because it's not changing speed. So there's no tangential acceleration. So the only acceleration is centripetal. It's the acceleration due to the change in direction. So that's going to be friction divided by the mass. So 1.60 times 10 to the 4th newtons, or kilogram meters per second squared. Could have written it that way to show the units canceling out. And that's divided by 750 kilograms. And solving that, the answer should come out to be 21.4 meters per second squared.